Cold stars, bright nebulae, and a rush through a glittering spiral arm. I punch it. Space stretches, stars smear, hyperspace. Today, 5 sci-fi technologies that physics says aren't pure fantasy. Let's count them down. 1. Warp-style travel, bending space-time itself. Imagine a starship sitting in a bubble. Space in front contracts, space behind expands. That's the Alcubierre drive idea. You don't move through space. Space moves around you. The catch: it needs negative energy density, something like the Casimir effect hints at, but on a cosmic scale. We've seen tiny vacuum energy effects in the lab, and we've mapped gravitational waves rippling space-time. So the math isn't magic, it's extreme engineering. If we can sculpt space-time, maybe with exotic quantum fields, faster than light isn't speed, it's geometry. Warp zoom. 1. Volumetric holograms and hard light projections. Not flat screens, true 3D light you can walk around. Today, optical traps can hold microscopic particles and paint images in mid-air. Acoustic fields can sculpt invisible pressure to float pixels you can actually feel. High-speed lasers, photopolymers, AR waveguides. Hard light is really force fields made of sound, light, or plasma, tiny rapid forces your skin reads as touch. Hologram grids flicker up, equations hang in the air. 1. Plasma swords, contained energy blades. Plasma is easy, superheated gas glowing like lightning. Containment is hard. You need magnetic bottles, like tokamaks. A handheld blade would be a compact magnetic nozzle sustaining ionized gas, power-dense beyond anything in your backpack. Lasers, microwaves, magnetic confinement shrink. Cutting torches that look like cyprops, constrained arcs in dense gas, and plasma jets shaped by electromagnetic fields. The glow is possible. The pocket reactor, still sci-fi. 1. Hover vehicles, speeders over sand and cities. Magnetic levitation already lifts trains with superconductors and changing fields. Hoverboards exist, over conductive tracks, using eddy currents. Lightweight superconductors, high-efficiency batteries, and precise control. And a speeder becomes a maglev drone, inches to meters off the ground. Add ducted fans or plasma actuators for lift and steering. It won't violate gravity, it will dance with it. Field lines, airflow, and feedback loops keeping you afloat. Dust kicks up beneath, HUDs glow. 1. Mind control interfaces. This one is here. Non-invasive headsets read EEG to move cursors. Implants read spikes to move robotic arms, type sentences, even synthesize speech. With better electrodes, optical neural probes, and AI decoders, intention turns into action. No joystick required. The frontier is bandwidth. Thousands to millions of neurons, stable for years, translating thought into motion, drones, vehicles, maybe shared realities. Brain signal graphics ripple like constellations. So, could we live in a galaxy of warp tunnels, solid holograms, glowing blades, floating bikes, and thought-driven machines? Physics doesn't say no. It says, bring energy, materials, and precision, and respect the edge where theory meets reality. The gap between starlit fiction and lab-lit fact is shrinking. One equation, one prototype, one breakthrough at a time. Warp transition to a quiet lab under a star field. On-screen text. Science isn't catching up to Star Wars, it's joining it. And I can't wait to see who builds the next piece.